As we head into section 6, we're looking at IP addressing fundamentals. We're going to do a binary conversion or two and give you an introduction to the routing process. So there is a lot going on in this section. And I'm also going to involve a Cisco router. We're not going to do full-blown labs yet because you need to get these fundamentals down first. And for some of you, you are very comfortable with this material. And for others, you're totally new to it. I'm going from the vantage point of someone who's totally new. I'm not assuming any prior knowledge, but I do strongly recommend, even if you are comfortable with the IP address classes, the binary conversions, what a /24 is, that kind of thing, go through this section anyway, because when you brush up on these fundamentals and they're second nature to you, it really helps on exam day when you're looking at more complex situations. A quick reminder here, since we've been spending so much time with MAC addresses up to this point, and for good reason, that when one host sends data to another, that data has two destination addresses. It has a MAC destination address and an IP destination address. Or if you want to put it that way, a layer 2 destination and a layer 3 destination. Up to this point, of course, we've been working with layer 2 destination addresses as opposed to layer 3 destination. We're now going to move up a layer in the OSI model to the addresses that, frankly, we use much more often in our commands than layer 2 addresses. Layer 2 addressing, everything we've looked at works so seamlessly and so well that we really don't even think about it a lot. And you tend to think, well, when data goes over there to a remote destination, then it just has one destination address. But please keep in mind, especially for your exams, that we're looking at two addresses there. You'll see a little later why I'm hammering you over the head with this. But for right now, let's start talking about these IP version 4 addresses, because that's what we're dealing with. The address format we've used so far, when you've seen an address like 10.111/24, something like that, that's an IP version 4 address. There's also IP version 6 out there, and that is not just 2 octets tacked on to the end of a version 4 address, believe me. And we will deal with IP version 6 later in the course. But to avoid any confusion here or in a meeting or on the exam, unless IP version 6 is specifically mentioned, we're talking about IP version 4. Just that simple. So I'm not going to continually say IP version 4 for the next 10 sections or however long it is until we get to version 6. Now, what's a routing process all about? Well, it's about moving packets across the network. We figured that, but also in the most efficient manner possible. It's not just enough to get packets from point A to point B. We want to get them there quickly and efficiently. Now, in this section, we're going to look at some general IP addressing info. There may be a little memorization involved for you if this is new information for you, but the good news I can give you, because I've been there and I've memorized this stuff too, it absolutely becomes second nature with more practice and more study. You won't even be thinking about it. So hang in there if this is the first time you've seen these address classes and then the reserved address classes. After we go over that, we're going to take an illustrated look at how routers make a decision on which path from source to destination is the best path, or what happens if, say, there's no path at all. So a lot of good stuff there. First, we're going to tackle these IP addresses and binary conversions, because every device on our network is going to have an IP address. And the laptop I'm writing this on, recording this on, no exception, just as this partial output of ipconfig shows. And ipconfig, of course, is a PC command. It's a Microsoft command, not a Cisco command. But you can see we've got something there called a link local IP version 6 address. And then we've got some IP version 4 information at the bottom. There's the address, there's the subnet mask, and there's the default gateway. So we got a pretty good idea what the IP version 4 address is all about, but what's going on with that subnet mask and default gateway? What is that stuff? Well, the thing is, you will need the skill of determining what network or subnet a particular IP address is on. And just point blank, you're going to need it for your exam. You're going to have the skill for job interviews. You're going to have the skill in real-world networking. It comes in handy. And when you have this down, you can solve any subnetting question Cisco asks you on the exams. Any. I'm going to show you how to do that, but this is the fundamental skill of solving any subnetting problem or any question. And the thing is, all we do is break the IP address and the subnet mask down to binary strings, and we do a bit-by-bit comparison. Sounds complicated. It's not. Don't let binary intimidate you either. because you will be nailing these conversions on exam day. You're going to nail them with a little bit of practice. That's a pretty fair trade. A little bit of practice, a lot of success. Sounds good to me. First thing we're going to do is convert that IP address 192.168.1.100 to a binary string from its current dotted decimal format. That's what we call that. And each one of those numbers is in a separate octet. We have 4 octets in an IPv4 address. And you have to convert each one of these numbers individually to a binary string. You're not just going to sit down and convert all of those numbers together. They are separated in that dotted decimal format, and that's the way we're going to convert them. Binary string, it's all ones and zeros, baby, and here's all we need to do to make this conversion. To convert 192 to binary, or any number, you only need this simple row of numbers from 128 to 1, going from left to right, and whatever number you're converting written down on the far left-hand side. Now, until this becomes second nature to you, the best way to remember, instead of trying to memorize these numbers, is just start from right to left and take the number 1 and double it 7 times. Because that's what I'm always telling people when it comes to subnetting questions, which we'll hit later. You know, if you can double the number 1 7 times, add and subtract, you can solve any question Cisco asks you on an exam. Any question. So we're going to start with that number 192, and all we're doing, going from left to right, is continually asking ourselves the question, can I subtract the number at the top from my current remainder? Sounds complicated. It's not. Here's how we do it. Very first thing you're asking yourself is, can I subtract 128 from 192, which is my current remainder? That's my number. And the answer is yes, I can. So I put a 1 under 128. And then I just subtract that number from my current remainder, or the beginning number, which is 192. So that's all I'm doing. 192 minus 128 equals 64. Can I subtract the next number in line, 64, from my current remainder of 64? Yes, I certainly can. So I put a 1 under 64. And you're almost done with your first binary conversion, because we have 0 left. And when you have 0 left, all you do is put a 0 under every other number that's remaining, and there's your binary conversion. So the decimal 192 converts to the binary string 11000000. It's just that simple. And here's what I've done as far as the entire number, the entire IP address, and the subnet mask. And I have broken the IP address down first. That's at the top. Font's a little smaller so I could get it all on one screen without having 2 rows of numbers. Then I've broken the mask down, and the mask, as you can see, is 24 ones, all ones for the first 3 octets, and then all zeros. So why do I care then about breaking down the subnet mask? We're going to address that coming up next.